All right, so 6-2 is all about parallelograms. So actually 6-2 and 6-3, but let's just do 6-2 first. So let's just talk about what a parallelogram is. I'm sure you've seen this before. If not, that's okay. So a parallelogram is a quadrilateral, so it has four sides, right? And then both pairs of opposite sides are parallel, as shown. So each opposite sides are parallel. Okay, so in a quadrilateral, opposite sides do not have or do not share a vertex, so they're opposite. Like this side and that side are opposite. And then opposite angles do not share a side. So if you hear me say opposite angles, that's what I mean. All right. So the first property that we're going to talk about, there's a lot of them for parallelograms, is opposite sides are congruent. So if they tell you it's a parallelogram, then just know that opposite sides are congruent. Okay. Let's talk about what the word consecutive angles are, or means. So consecutive angles are whenever they, like consecutive means like in a row kind of. So like A and B are consecutive. And then B and C would be consecutive. C and D would be consecutive. And D and A would be consecutive. So it means like they're kind of they're right next to each other, okay? So whenever you're doing these, consecutive angles right here are supplementary. So A and B add up to be 180. B and C add up to be 180. Oops. And then C and D add up to be 180. And then lastly, of course, D and A add up to 180. So if there's angles that are next to each other, they add up to be 180 on a parallelogram. All right, if angles are opposite angles in a parallelogram are congruent, so they're equal. So like in this diagram, A and C are congruent and B and D are congruent. And then is there one more on this page? Okay. Yes. So the diagonals are congruent. Actually, I don't think we need that yet. Let's wait. Okay, we don't need that. Let's just stay on this page. Sorry, I couldn't tell where the page ended. So we have those three things. So we know opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary. All right, so we need to solve for three different variables. There's a lot going on in this parallelogram. So let's just go ahead and mark on it what we know about this. So we know this side and this side is congruent. This side and this side is congruent. We know this angle and this angle is congruent. And then the other opposite angle and the other opposite angle are congruent. So, and then we also know that the consecutive angles add to be 180. Okay, so let's first start with number 1, which is where we solve for x. So we know the only part that has x in it is this side right here. So we know this side is equal to this side because it's a parallelogram. So then that tells us we can set up our equation. 37 equals 2x minus 3. Sweet, we have a two-step equation. Let's go ahead and solve it. We're going to add 3 to both sides. That gives us 40 equals 2x. Then divide by 2. So x equals 20. Not too bad, right? Okay, now let's solve for y. Where's y at in this problem? Looks like it's right here. So y is that angle, y degrees. So that means that it's the same. Opposite angles are congruent as this angle. So we don't even have to do any math on this one. Y is going to be 23. So y equals, or sorry, not 23, 123. Okay, let's do z. So on z, this is this angle right here, so we're dealing with angles. So z let's see if the opposite angle is, nope, they don't tell us anything could only be that easy, right? If they told us what this was, we automatically would know what Z was, but they don't. That's okay. So Z, what else do you know about the angles in a parallelogram? Well, we know that consecutive angles add to be 180. And these two right here are consecutive. So this angle plus this angle equals 180. So we're going to set up our equation to find out that Z plus 123 equals 180. Okay, let's go ahead and solve it. So let's subtract 123. That's the only step. It's a one-stepper. So Z equals 57 degrees. Okay, so that is it for that problem. It's kind of a cool problem. There's a lot of steps in it. You're also going to have a lot of problems like that on your homework where it's going to want you to find multiple things. All right, let's go on to the next page. Oh, I skipped one, sorry. Okay, so first, another thing about quadrilaterals is their diagonals. So the word diagonal you probably haven't seen, or maybe you have. So diagonal is when you take and you put make a line that goes across a polygon and it connects with another vertex. So some shapes have multiple diagonals, some only have just two. But yeah, so we're going to be dealing with diagonals. So on a polygon, this is true for a polygon, not for everything. So if it's a polygon, then their diagonals, the diagonals of a polygon, bisect each other. So that means that they cut each other in half. So this and this are congruent, and then this and this is also congruent. Okay. So it's just something else to put in your cap about polygons. So solve a system of linear equations to find the values of x and y in the parallelogram, same polygon, I meant parallelogram, KLMN. What are KM and LN? So they want us to find what x and y is, and then they also want us to find the distance of KM and LN. So that's the whole way across. So we have four things we're solving for. So first, I'm just going to highlight again. So this and this, those are congruent, and this and this. So this is actually some Algebra 1 stuff, which is kind of cool. It's a system. So I'm going to write it out. Let's do the green ones first. So we have x is going to equal y plus 2. Okay, we know that's true. And then the other one, the red ones, are going to be y plus 10 is going to equal 2x minus 8. Okay, so now we have two equations going on. As it's written, we can't just solve for x or solve for y because both problems have x and y in them, which is kind of inconvenient, but there's still a way to solve it. Don't you worry, we're going to get it solved. So I don't know if you remember from Algebra 1, but there is, this is called a system of equations, and there's a few different methods to solving these. It looks like the easiest one for this problem, and most of them, is substitution. So on this, since we already have a variable by itself, x equals all this stuff, that makes substitution a lot easier. So we are going to plug all of this in for this x right here. Okay, so let's go ahead and write it out. That would be y plus 10 equals, now there's a 2 being multiplied by that x, so you have to put some parentheses there. So 2 times all of that stuff, so y plus 2 minus 8. So that's the part that I plugged in right there. Okay, so now we have an equation with just y's in it. Good, that's what we need to do. Now we can solve for y. So the first step we need to do is distribute. So that would give me 2y plus 4, and then bring everything else down. Then let's go ahead and combine like terms over on the right side. So I'm going to drop everything else down, and then I have positive 4 minus 8 That would give me -4. All right, now let's go ahead and get all of my y's on one side. So I'm going to pick to move them over to the right. So -y, -y. Those cancel. 2y minus y is y. -4. And bring everything else down. Almost done, last step. So we're going to add 4, add 4. So those cancel and you have y equals 14. Good, that's one of our answers. Okay, so now how can we figure out what x equals? Well, it's actually easier than how we solved for that. So now that we know y equals 14, I'm going to take this 14, because that's what y equals, and plug it in right here for this y. So x equals 14 plus 2. And that's it. Let's go ahead and solve it real fast. X equals 16. Good. Okay, so now we got x and y, and now they wanted us to solve what km and ln are. So I'm going to draw some little lines here. So km is the whole way across. There's a few different ways you could look at it. You can find, like, this is what I'm going to do. I'm going to find out what this piece is from here to here. Actually, let's do it in blue. So from here to here, I'm going to find out what that is, and then I'm going to double it because the other side is congruent. So to do that, I would have y plus 10. Okay, so y is 14, so that's 14 plus 10. It'll be 24. So this is 24. Then we have to double it because the other side is also 24. So 24 plus 24, km is going to equal 48. Not too bad, right? ln is actually easier. So it's similar how we solve it. I'm going to solve for this piece right here. And look, hey, it's just x, so that makes it easy. So our x is 16. So if this is 16, this is 16. So we have to solve out all the way across. So 16 plus 16, ln equals 32. All right, so now I'm going to box my answers, and I believe we now have all 4 answers to satisfy this problem. Yep, we do. Okay, next problem, last one. This one, it looks really crazy and confusing, but it actually makes it pretty easy. So if they tell you these lines, you have parallel lines, and you have a line going through a parallel lines. Remember, that's called a transversal. Okay, we've done some stuff with that. So if you have transversals through parallel lines, in this case there's 2. This would be a transversal and this would be a transversal, okay? So if they're parallel lines going through it, and they tell you that one transversal is cut into equal pieces with the parallel lines, then that means that the other is also cut into equal pieces. Okay? Good. But it has to be true that their lines are parallel and it's cut into equal pieces by one transversal. You could have up to 1,000,000 transversals. I think on the homework problem there's one that has like 3 or maybe 4. I think it's just 3. Okay, and there's kind of a lot going on, but it's still kind of cool. Okay, in the figure, AE, BF, CG, and DH are all parallel. Okay, good. They mark those with the arrows. All right, the next line says AB is equal to BC, which is equal to CD, which is equal to 2. So that tells you that they're all congruent and they all equal 2. All right, so if they're all congruent and those lines are parallel, then that must mean these are all congruent as well, given our theorem. So if EF is 2.25, what is EH? So if that's 2.25, then that means all of these, the other two, must be 2.25. And we are trying to figure out what it is the whole way across, right? So from there to there. So that would be 2.25 plus 2.25 plus 2.25, or you could say 2.25 times 3, which gives you EH is going to equal, add up all of those, and you get 3.75. And that's it. That's, yeah. Oh, not 3. It's 6. My bad. I'm sorry. So it is 6.75. Can't do math. That's why I teach it, right? Just kidding. Okay, so it's 6.75. That is your answer. And that's actually it for the notes. So thank you for watching and have a great rest of your day.